Hello! Welcome to my first ever attempt at a Unity tutorial. I've only just recently started using Unity, but I thought I would share with you something that I've learned. So without further ado, here's a demo of what you would expect to achieve by the end of this video. And that's it. Interested? Well, let's move on. Before we begin, I'll have to remind you that this tutorial is meant to be used in a 2D canvas. I've already gone ahead and created a new project. But if you haven't, do create one using the 2D mobile template. Or if you accidentally created one in 3D instead, just go to your main camera and set it to orthographic like so. Once that's done, it's time to create some objects. First, we create a canvas object. Set its render mode to screen space camera, and then drag our main camera into the render camera field. This will cause our canvas to encompass the entire camera. Next, we'll be creating two raw image objects, one being the child of the other. We're gonna name the parent Mask and the child Reveal. Then, we drag our image asset into the texture field of the parent object. You can use any image that you wish. Let's hide the child object for now to have a clearer view. Oh, and before I forget, do make sure to go to your image asset, check the Read Write Enabled checkbox, and then hit apply. Now our little guy here seems like it got stepped on by Mario, so in order to fix this, we add in an aspect ratio filter component. Set it to whichever mode you prefer, but in my case, I am using the height controls width mode. Go back to the image asset to confirm its width and height. This guy seems to be 620 by 794. Then we go to the parent object and input the aspect ratio, 620 by 794. Alright, now our little guy looks great, but it's a little bit too small, so let's blow him up a little bit. Okay, now we go to the child object, re-enable it, and set its rect transform to stretch both vertically and horizontally, setting the left, top, right, and bottom values to 0. And we can see that the child object stretches fully to cover the parent object. Once we're done with that, go back to the parent object and add in a mask component. What this component does is that it only shows part of the children object that is within the visible areas of the image of the parent object. So once we apply the mask component, it should only show the white image of the child object, but in the shape of our little guy. Now on to scripting. Go ahead and create a new C# script file and call it brush reveal. Open that up and we'll start off with adding some namespaces that we'll be using. You can ignore the system namespace, I only added that because I had to do some debugging of video. Event systems is used for the click and drag event handlers. Events namespace for Unity event class, and finally the UI namespace for referencing our UI components. We will be inheriting two classes which will be used for detecting drag events. They are the iDrag handler and the inDrag handler. Remove the update function since we won't be using it. Then we implement the functions required for the classes we've just inherited. The onDrag function will be called every time the mouse is being dragged, but not when the mouse is clicked. Now duplicate that function and rename it to onAndDrag, which will be called when the mouse is released after dragging. Now it's time to declare some variables. Reveal obj is used to store a reference to our child object that we've previously named Reveal. OnSelf will be invoked when the image is fully revealed. R will be the radius of our brush circle. Rect transform to store a reference to our rect transform component. Texture to store a reference to our mask image. Original pixels to store the pixel array of our image to be revealed. A boolean to check our solved state. And finally, solve percentage, which we will be using to do things like once 80% of this image is revealed, consider it fully revealed. We'll also be adding in a range of 0 to 100 for this variable. With our variables declared, let's initialize them. We start off by getting the raw image component of our game object. Create a temporary reference to its texture, which in this case is the image of the little guy. Assign this texture to the child object's raw image component, so that when it is revealed, it is revealing an actual image instead of a white square. Next, we assign the texture's pixel data to the original pixels variable. Then, using the same texture's width and height, we create a new texture 2D object, and then we assign it to our class declared texture variable. This basically just creates a blank texture 2D object with the same dimensions. Create a reference to the blank texture's pixel array, and we'll loop through each pixel, making them all transparent. Set the pixel array to our texture variable and apply it. After that, we'll set it to the raw image component's texture. Almost forgot to get our rect transform reference. So long story short, we now have a start function that gets the mask object's image, then sets it as the reveal object's image. It then creates a new transparent image with the same dimensions, and then replaces the original mask object's image. Save the file and go back to Unity. Apply our script to the mask object and drag the reveal object to the script's corresponding field. Hit play and we'll see that the mask object has a completely transparent image, and the reveal object has the little guy's image. Now it's time to code the actual brush reveal. In the onDrag function, we'll check if it's already solved, and if it is, we do nothing. Create a new vector2 object which we'll call local cursor. This will be used to store the location of our mouse as it's being dragged. Then we'll call a pretty long function. Get ready, React Transform Utility.ScreenPoint to local point in rectangle. I'll explain in a bit what this function does after we plug in the parameters. So we put in our rect transform reference first, then the position of the mouse on screen which we get from the pointer event data object that the onDrag function provides. Then the camera associated with the drag event, and lastly the local cursor variable we just created. What this function does is that it uses the rect transform's pivot point as the origin and returns the mouse position. To demonstrate this, I'll print out the output and comment out the line that sets the transparent image to temporarily show everything. I'm also going to be disabling the mask component and create an image object inside, stretching it across the parent so that we can see where our mouse is in the rect transform. Now as I move the mouse around, the closer we are to the pivot point, which in this case is the center of the image, the closer it is to point 0, 0. We can test this by changing the pivot point, and now it is 0, 0 at the bottom left corner. Back to the code editor, I kinda messed up the recording a bit, so do remember to uncomment this line. Now before we move on, I'll quickly explain how the color array we get from the texture's getPixels function works. Take these pixels for example. The function arranges these pixels from left to right, bottom to top, and flattens all these down to a one-dimensional array. Because of this, we need to have our mouse position to be relative to the bottom left corner, since that is where the first pixel in the array is at. To do this, we just need to subtract the mouse position that we got with the pivot point of our rect transform, like so. Now I know we can always set the pivot point to the bottom left corner to omit this step, but doing this extra step will allow us to have our pivot point anywhere we want for more flexible placements of our game object. Before proceeding, we'll need to create a new function which we'll call withinRange. This function checks whether a value is equal to or larger than 0 and lesser than a specified value. We'll use this function to check whether our mouse position is within the rect transform's boundaries. Otherwise, we'll be getting undesirable effects or even out of range exceptions. Then we'll need to normalize the mouse position to a value between 0 and 1. That way we can scale the rect transform however much we want and still get the same results. We do this simply by dividing the mouse position with the size of the rect transform. Once that's done, we can finally get the mouse position in our texture by multiplying the normalized mouse position with the texture's dimensions. Okay, now we'll quickly create some variables first and then I'll explain what they do. This batch of variables will be used in math calculations. Store a copy of our texture's pixel array, as well as the x and y values of the mouse position. With these variables set up, it's time to answer the question. How are we supposed to reveal the child image? Well, we've got ourselves our transparent mask texture, the mouse position in the texture we just calculated, and the radius we declared at the start. All we gotta do is use this information and paint a solid color circle in the mask texture. This results in parts of the child object that are within the painted areas to be revealed. To paint the circle in the texture, we need to get the position of all the pixels within the circle. And to save time, we will split the circle into 4 quadrants. That way, just by calculating one quadrant, we can easily mirror them to the other 3. We'll be calculating the pixels within a quadrant by doing a loop. We get a value of x, loop through the pixels all the way to y, move on to the next value of x and loop up to y again. Then we do this all the way to the end. Now we know that the value to loop left to right is just the radius. But what about bottom to top, which is this curve over here? Take a value of x for example. To get y, just plot a triangle here and use good old Pythagorean theorem to get what we want. Whenever we get an x and y value, we calculate the pixels' coordinates in the texture by adding the values to the mouse position. px/py just means positive x and positive y. Adding the y value but subtracting the x value, we get a pixel for this quadrant. And x and y denoting negative x and negative y. Now for the following portion of the script, I did reference it from a post in Unity forums, so due credits given to the user Pajama Jama. We begin with the loop from left to right, and then using Pythagorean theorem, we'll calculate the bottom to top value to loop through. Once we have both the x and y values, we will calculate the positive and negative values from the mouse position. Let's work on the pixel in the first quadrant, using the positive values of x and y, px and py. Now remember how the pixel array is one-dimensional? Yes, now we have to convert the px and py into an index in the array. It's pretty simple actually. We multiply py with the texture's width and then add px. With the index calculated, we set the pixel to a solid white color. And then we do the same for the other three quadrants. Set the pixels to our texture and apply. Now go back to Unity, hit play and admire your work. But notice how when you brush near the edge, it loops around to the other side? That's because we didn't check the range of the pixel's coordinates. Now go back to your code editor, and for each quadrant pixel, check that its x and y value is within the texture's width and height respectively. Test it again, and we see that the looping issue has been fixed. Now there is still a tiny bug left to fix. If you try to brush the bottom edge, you will notice that the first row of pixels are also being affected. Over here in the textures preview, you can see that we did not accidentally paint the top row. It is completely transparent. Why does this happen? Well, that's because by default, when you create a new texture 2D object by code, its wrap mode is defaulted to repeat. So knowing this, all we have to do now is go back to the code editor, and right after we apply the texture, we set the wrap mode to clamp. Test this again in Unity, and the white line above is gone. Finally, we get to test this mask on our actual image. Go ahead and uncheck Show Mask Graphic, disable the test object, and hit play. And voila! Now onto the final step, checking whether the image is considered revealed. We do this by comparing the alpha values of the pixels from the mask's texture with the ones from the texture that's to be revealed. Over in the onAndDrag function, we start off by checking if it's already solved. Get a copy of the mask texture's pixels. Create a new variable that keeps track of the number of pixels in the texture that are opaque, meaning pixels that have an alpha value of 255. We are only considering fully opaque pixels as valid, not the semi-opaque ones. Next variable will be used to keep track of the number of revealed pixels. When the pixels of the same position in both the mask and the reveal texture have an alpha value of 255, we add to this count. We simply loop through the reveal texture's pixel and check its alpha value. Again, we are only considering fully opaque ones. If you want to include semi ones, then you should check for alpha values above 0, or however much you consider as semi-opaque. Add to the opaque pixels count. Check the alpha value of the pixel in the mask texture using the same index. Add to the revealed pixels count if it is opaque. After that, we'll calculate the percentage of pixels revealed and compare this value with the solve percentage variable we declared at the start. If it is equal to or higher, then we consider this fully revealed. Then we loop through our mask texture's pixels, set every single one of them to a solid white color to fully reveal the image. Set it to the texture and apply. Invoke our onSolve Unity event, and we're done. Now let's go back to Unity and give a final test. Before we hit play, set the solve percentage to say 80. Try to reveal roughly 80% of the image and release the mouse. Success! Now if you feel that the final reveal is too abrupt, you can always add in an object that fades in when the onSolved event is invoked. If you would like to see how that can be done, let me know down in the comments and I might make a continuation to this tutorial. Maybe using a custom texture as a brush? Anyway, that's it for this tutorial. If you have any questions, suggestions, or even better ways to improve what's been shown in the tutorial, comment away. If you like what you see and learned something useful, do consider clicking the like button. Oh, also, I do have an Instagram channel where I post weekly comics and a Twitch channel where I stream random stuff.
He's very lazy and rarely streams at all.
Thank you very much for watching this video. Have a great day and goodbye!